100 years, TV displays have come a long way, and they continue to change. Chemists at the University of British Columbia are uncovering what could be the future of these display technologies.
Iridium is used, and actually in most OLED screens, Samsung ones, the green pixel is an iridium complex. But iridium is super expensive, one of the least abundant metals in the Earth's crust.
This is Dr. Christopher Brown, a postdoc in the UBC Department of Chemistry. Recently, he has observed an unusual property of copper.
And for complete transparency, this was one of those serendipitous moments where you see something interesting and you kind of run with it. So there's a lot of research going on in the photophysical community looking at copper emitters, because if you can get one that's really efficient, and if you can get that, then obviously the cost of manufacturing goes down. There's a lot that you can gain from using an earth-abundant metal like copper.
Pause. Let's rewind for a moment. You might be wondering what an emitter is. Emitters are chemical compounds that, when stimulated, emit light. These emitters make up many of today's TV and smartphone OLED displays. OLEDs, short for organic light-emitting diodes, are often made from iridium, a rare earth metal.
Like, it's super expensive, but copper is $5 a kilo. There's a lot that you can gain from using an earth-abundant metal like copper.
But there's a trade-off. When copper is excited, it undergoes a change in geometry, a relaxation that makes it less efficient. Dr. Brown has found a way around this.
So if you can tune it, that you can keep it locked in this tetrahedral shape, you inherently make it more efficient.
What would be the easiest way if you're trying to explain this to somebody who just has no chemistry background?
Okay. You make a powder, you isolate it, literally by precipitation, and then you filter it out. Which is why copper chemistry is so nice, is that you can get a pure compound relatively easily compared to other things. You heat it up, and then the emission color is different. So the emission color is the color that you get off. So if you are exciting it with a black light, 365 nanometers, you put it on the powder and you get an orange emission after heating, but before heating you get this yellow emission. This work is definitely more fundamental. I can't see being used in a screen, because to change its color you have to cool it down a lot. But also to put it into an application or a device would be tough. This is tough because you always have to give an application, whereas deep down you might know that it probably doesn't have one. Not everything you publish has to be this complete story. Sometimes it's worth just getting it out there, and then maybe within the group you develop it further.